Okay, there we go. So systems of linear equations, solving with substitution and elimination. There will actually be some in the homework that are literal algebra 1 problems where it's a 2x2 system. Most of them are going to be 3x3 systems because that is the, more college level system, but they want to review those 2x2s just to make sure you know what you're doing. So in general, we can solve systems of equations by graphing substitution or elimination. Substitution and elimination are the two algebraic options, which is what it will generally ask you for. The graphing, you won't be asked to graph any 3x3s because that would require three-dimensional graphing, which I do not believe know how to do at this point. That is a thing, though, if you decide to continue your math career. But there may be some that ask you to graph the lines on a 2x2 in the homework as well. We should know how to graph lines by now, so I'm not going to go over that one. The answers are ordered pairs, which represent the intersection point. We also can have systems that are no solution, which on the graph is represented by parallel lines. The lines are parallel, they obviously don't intersect, and since the answer is the intersection, that means there's no solution. We call those types of systems inconsistent. So when it asks you to classify the system, that's what it means. So the answer is either an ordered pair, or when we get to 3x3s, an ordered triple, or you say no solution, or we're going to have some that are infinitely many solutions. That's the answer. When it asks you to classify it, that is going to be consistent, inconsistent. And it could have infinitely many solutions. On the graph, that would be if the two equations produce the same line. Which for those are consistent systems. I've got that written down here. But the way that we write in college, this part will be new for everyone because you don't do this in high school algebra. When you have infinitely many solutions, you write it as either, if it's a 2x2 system, you write x comma y, which is just telling you the format of the answer. If it's a 2x2 system, the answer is an ordered pair such that, and then you write an equation. So either x equals some expression or y equals some expression. Basically, whatever you end up with x or y equal to. For a 3x3 system, the format of our answers are ordered triples. So we would write that on the left side, and then the little such that bar. And then you have to write multiple expressions. It does not matter which variable you use. So your infinitely many solution answer might look different than someone else's and still be right. But the key is that you have one of your three variables, x, y, or z, that is just x, y, or z. So let's just say, for the sake of ease, that x is going to be the one that is just itself. So we would write x, and then y equals expression with x, so meaning writing what y is in terms of x, and then z equals another expression with x. So that might be xyz such that x comma y equals 3x plus 2, z equals 6x minus 5, for instance. And again, I'll show you when we get to one of those in the examples. When you have 3 variables, so we should know how to solve 2 variable systems with both substitution and elimination. That's a big part of Algebra 1, and you review it in Algebra 2. When we move to 3 variables, your first objective is to obtain a 2x2 system. In order to do that, you have to get rid of one of the variables. I almost always use elimination unless I have equations that already don't have some of my variables. Because if some of your equations only have an x or only have a y or only have an x and a y, then that using and taking advantage of that can make it less work. And I tried to pick examples that would kind of illustrate that as we go. Once you have done that, then it goes back to exactly what Algebra 1 is. Solve the 2x2 system. You can use substitution or you can use elimination for that. It does not matter to me. You must show all of your steps. Once you've solved the 2x2 system, since it is a 3x3, you then have to plug those answers into one of the original equations and solve it. So our final answer should be an ordered triple x, y, z. So what we are going to do, first we'll briefly review the 2x2 system. So you have choices. I am going to use elimination most of the time, so I'm going to use substitution on this one just to review it in case you happen to be a substitution person. I don't want to leave you out, but I do use elimination more often, so I'll use substitution on this one. Our first objective, if we are solving a system with substitution, is to get one of my 4 variables alone. Typically, there is a best choice. That doesn't mean it's a right choice and a wrong choice. I can solve for any of those 4 variables, and as long as I do the algebra correctly, I should get the right answer. However, it is much, much less work to solve for the y in this equation than to solve for any of the other things, because the other variables all have a coefficient that's not 1, which means I'm going to have to divide, which means that's going to create fractions, which means I then have to plug in fractions. Again, it's not wrong, it's just much more time consuming. So we try to make the best choices possible. And so I am going to get y alone in this second equation because that is the fastest choice. So in order to do that, I would subtract 10x on both sides. So that gives me y equals negative 10x plus 11. And when I have isolated one of my variables, so x or y from one of the equations, the reason I do that is so that I can substitute the expression. So this guy right here, negative 10x plus 11, is equal to y, which means it is the same as y. So now I am going to substitute this expression into the other, I don't know why my O is so far away from the T, into the other equation. So not the same equation that I just solved for y, it has to be the other one. So negative 10x plus 11 is the same as y. So I am going to take y out of this top equation and I'm going to put negative 10x plus 11 in its place. So everything else about that equation is going to stay the same. So I've got 2x minus 3 still. But again, in place of the y, I'm now putting in that negative 10x plus 11. Again, everything else has stayed the same. I still have 2x, I still have a minus, I still have the 3, I still have equals negative 1. The only thing I changed was in place of that y, I substituted the equivalent expression. Now this is a one variable equation. I should hopefully be able to solve it very easily. So I will distribute first. And then I will combine like terms. So 2x plus 30x is 32x. Then I need to get x alone. So add 33 to both sides. So 32x equals 32. Divide, and I see that x is equal to 1. Just because I have x equals does not mean that I am done. In fact, I am not done ever if it is a system, because system means I have multiple variables. So I now know what x is. Once I know what x is, I then need to plug that in. It's easiest to plug it in here because that's already, y is already alone. So if I want to know what y equals, it's negative 10 times x, which I now know is 1 plus 11. So y equals negative 10 plus 11, which is also 1. You must write your answer as an ordered pair. That is how final answers on 2x2 should look. It does not matter if you are solving by graphing, solving by substitution, or solving by elimination. The answer should be an ordered pair if it's a 2x2 system. The only time I would not write an ordered pair are what we have already talked about up at the top, no solution or infinitely many solutions, where we would follow what we did up there. Again, if it asks you to classify, this one just said solve the system, but if it had asked me to classify it, consistent is or inconsistent is only if there's no solution. It's consistent if there's a solution or multiple solutions. So this would be consistent, and it would also be independent because there's just one. All right, we are going to go through, I think, I always put extra on here. I think we can probably get to 2 of these 3x3s. And then plus show you how to check the answer on the graphing calculator. Again, you will not get credit if all you do is the graphing calculator. The graphing calculator is to help you know if you've gone astray, right? But it is not, the work. Okay. So my first objective is to obtain a 2x2 system. And when I do that, I always do that with elimination. I think it's way easier once I move to 3 variables to get it down to 2 if we use the elimination method. Now, what I was talking about earlier with noticing when you already don't have a variable, it is going to be less work for you if you eliminate z, because this second equation already doesn't have z, which means I've already got half of my 2x2 system if I reuse this equation. So if I want to take this guy back up here for when I get to my 2x2, 4x minus y equals negative 5. That's half of my 2x2 that I already have because that second equation happened to not have a z. Now what I need to do, and if you have all three variables in all three equations, you're going to have to do this twice. And I will model that in the next example that we do. But I am going to have to pick a pair of equations. Obviously, in this case, I'm going to pick equation 1 and equation 3 to eliminate that variable. So z is already eliminated in the middle equation. So I'm going to pick a pair of equations, equation 1 and equation 3, and I'm going to get rid of z. So I'm just going to recopy them below with them set up to eliminate. So if I am looking at equation 1 and equation 3, and I know I want to get rid of the z's, in order to get rid of them, hopefully you recall from Algebra 1 and Algebra 2, that we can eliminate them when they are opposites, right? So clearly, -3 and +5 are not opposites. Opposites are +5 and -5, +10 and -10, whatever the case may be. So I'm going to have to multiply these equations by some constants in order to make them opposites. So what is the smallest number that I could turn these into that would be opposites? 15. Very good. So 15, and then obviously the opposite of that is -15. So here is how I organize my work. You do not have to use my particular organization method, but it does need to be organized. Some of you, it's not just that your handwriting is messy, it's that you put things all over the place. I am telling you, I'm not going to be able to find it on these. You have to come up with a way. If my way doesn't work for you, fine, but I need to be able to follow your work. Like I went here, then I did this, then I did that. Because otherwise I'm not going to be able to find your mistake. There's just too much algebra on every single page. So I'm going to take equation 1. So I'm writing a circled 1 to represent equation 1. In order to make that a 15, where it's currently a 5, I need to multiply it by 3. So I'm just going to write a 3 out in front. So that's representing that I'm taking 3 times equation 1. So 3 times equation 1, again, that means the entire equation. I can't just turn a 5z into a 15z. I have to multiply the entire equation by the same thing to make that conversion. So I'm multiplying the entire equation 1 by 3, which is going to give me 6x minus 12y plus 15z equals -99. Then, similarly, if this says positive 15z, I want to turn this -3z into a -15z, which means I need to multiply by what number? 5. So 5 times equation 3. Again, every single piece has to be multiplied by the 5. So -10x plus 10y minus 15z equals 19 times 5, 95. And so now I have the desired opposites on the z's. Again, I chose to eliminate z because I already had z eliminated here. You can choose to eliminate whatever variable you want, which I think you can then be intuitive and realize that everyone's work could look completely different, which is, again, why I need to be able to follow where you went in your work. So once I have opposites, I now am going to add straight down. That's what we do in the elimination method. I'm going to add straight down in columns. So 6x plus -10x is -4x. -12y plus 10y is -2y. the z's were opposites, the whole purpose of that is to eliminate them because they become 0. So those go away. Negative 99 plus positive 95 is negative 4. So this is the other half of my 2 by 2 system. So I take this guy and put it up here. So this part right here is the Algebra 2 / college level math. The rest of it is now just back to an Algebra 1 problem because now I have exactly what I did in example A. I've got a 2 by 2 system. I already have opposites on the x's there. Now, of course, that won't always happen. That's kind of lucky in this case. But that means that I can use the elimination method. I already reviewed the substitution method over here. You can solve your 2 by 2 however you want. But because they're already opposites, it's going to be much faster to use the elimination method because I add straight down and the x's go away. The y's, negative y plus negative 2y is negative 3y. And then negative 5 plus negative 4 is negative 9. So, again, solving for y, so divide by negative 3. Y equals 3. Just like I did over in example 1. Once I know the value of one of the variables, I plug it in. I need to plug it into the 2 by 2, right? Because I am not done solving the 2 by 2 yet. So if y is 3, I'm going to put that into one of these equations. It does not matter which. I'll just use the top one. So 4x minus 3 equals negative 5. So add 3 to both sides. 4x equals negative 2. Divide by 4. Please stop telling me that that is negative 2. The bottom number is bigger. Yes, they are both divisible by 2, but the answer is not 2. It's negative 1/2. So I know what y is. I now know what x is because I've solved the 2 by 2. Now I go back to the Algebra 2 / college level, and I plug the answers from the 2 by 2 into one of the original equations. That's going to help me solve for z. Obviously, in this case, I cannot choose the second original equation. It doesn't have a z. I have to choose one that does. Again, does it matter at all whether I use equation 1 or equation 3? No, it doesn't. Whichever one you happen to prefer is fine. I will probably use the top one just because the x term isn't negative, but it doesn't really matter. So 2 times x, so I'm taking both of these and plugging them in here. So x is negative 1/2 minus 4 times y, which is 3, plus 5z equals negative 33. 2 times negative 1/2 gives me negative 1. This gives me minus 12 plus 5z. Combine the like terms. Negative 1 and negative 12 gives me negative 13. And so then solve for z. First by adding 13 to both sides. That gives me 5z equals negative 20. And z equals negative 4. So I have all 3 variables and what their values are. So ordered triples work just like ordered pairs. It goes in alphabetical order. So x comma y comma z. So negative 1/2 comma 3 comma negative 4 would be the final answer. just like you learned in Algebra 1, if you plug in the ordered pair, it should work in all of the equations. If it doesn't, then you've done something wrong. I am going to show you how to check it on the graphing calculator once we get to that point here. So what I'm going to do now is show you what we have to do if you don't have a visible shortcut. So I showed you how we could make less work for ourselves with a visible shortcut. So using the fact that Z was already eliminated, we went ahead and eliminated Z. If that is not the case, then I have to do this step right here twice. It can be with any two pairs. Again, there are better choices, but there aren't right and wrong choices. There are just easier choices. So when I look at example D here, I have all three variables in all three equations. So when that happens, strategically, I want to look at all the variables and see if one of them is easier to eliminate than the other. So if you already have opposites, then that's a good way to say, oh, I want to eliminate this because I already have opposites. When I look at these, I don't really already have opposites. I would say that X and Z are fairly similar in ease. The reason I'm saying those are easier than Y is I don't have any plain Y or negative Y's. So it'll be just a little more difficult to eliminate Y than it would be X or Z. X and Z are going to be almost the same amount of work. I'm going to choose Z only because this one's already negative, which means I don't have to multiply through by negative numbers, which generally when we multiply by negatives, people make more mistakes. So that's why I'm going to choose to eliminate Z. So I am going to pick a pair. I am always going to use this one because it's just a 1, right? A negative 1, really, which means I can multiply it by anything to make it the opposite of the other one. So my first pair, I'm going to choose equation 1 and equation 2. In order to get opposites on Z, I would have to multiply equation 1 by 2. So multiply equation 1 by 2, and I'm going to use equation 2 as is. So I'm not writing any number in front of it. And I'm writing a note to myself that I am eliminating Z. Again, the more organized you can make your work, the better chance you have for me giving you partial credit. Because I'm sorry if it takes me 5 minutes to figure out one of your problems, I'm not doing it. Because I have 50-ish students. I cannot do that. So 2 times equation 1. If I multiply all of equation 1 by 2, I would get this. Equation 2 as is means just copy what I see. So 3x plus 2y plus 2z equals 2. Again, my objective is to eliminate z. When I add, I get 7x minus 4y, the z's go away, equals 2. So I have half of my 2 by 2. It is not a 2 by 2 if they do not have the same variables. You cannot eliminate z in the first pair and eliminate something else in the next pair. I have to eliminate the same variable. So for that reason, my other pair, I already chose equation 1 with equation 2. So I'm going to choose equation 1 with 3 because it's easier to get opposites. You can do 2 with 3. It's not wrong. It's just more difficult. So I'm going to choose to multiply equation 1 by 3 and use equation 3 as is, also eliminating z. So 3 times equation 1, equation 3 as is, Again, notice I'm eliminating the same variable. Those are going to go away. I get 7x minus 4y equals 2. That is the other half of my 2 by 2. Now, you may already know the answer, but when we are solving that 2 by 2, what we would be doing is either using substitution or elimination. If I want to use elimination, I would multiply the second equation by -1. So multiply by -1. So negative 7x plus 4y equals -2. When I add those then, I get 0 equals 0, which tells me what about my solutions? Infinitely many. If you have forgotten how to tell the difference algebraically between no solution and infinitely many solutions, in both of them, all your variables drop out. You have to look to see what's left. If what's left is true, then that means it's infinitely many solutions. If what's left is false, like 0 equals 5 or -2 equals 7, then that would be a no solution. So this is infinitely many solutions. And again, now that we are in big boy and big girl math, we don't just write infinitely many solutions. We write it in this format up here. So x comma y comma z. And, bless you, if I solve this equation for one of the variables, it doesn't matter. Let's say I solve it for y. That would be -4y equals -7x plus 2. So y equals, when I divide by 4, 7/4 x minus, minus 2/4, which would be 1/2. So I can let x equal x, y equals 7/4 x minus 1/2. And then z is going to be in terms of y and x. So I would go up to this top equation because I can just add z to the other side. And then z is alone. So 2x minus 3y. Again, if I had chosen to solve this for x instead of y, how I write that would look different, and that's okay, right? They can all be correct descriptors and be different than what someone else has, as long as you've done the algebra correct. Question was, am I supposed to write z equals? And yes, I absolutely should write z equals. Technically, it wouldn't be wrong if you didn't write them, but I should be consistent. So if I didn't write y equals here, if I just put 7/4 x minus 1/2, then I could just write 2x minus 3y. But whatever you choose should be consistent, so I should write it in this case. Okay. Now I'm going to show you how to check your solutions on the graphing calculator. I do have all the screenshots here, so you should be able to do this yourself as well. So this is the example of the 3x3 system. You can do it for 2x2s as well. You have to use matrices. which on your calculator, the matrix button is in whatever color your second button is, but it's right below the math button. And so you have to go there first. So I press second and then there. And notice it says edit. So I need to scroll right so that I am highlighting the edit button. And I need to tell it what size it is. Now this is slightly confusing. It's a 3x3 system of equations, but the matrix size needs to be 3x4 because it's rows by columns. And since we have constants as one of our columns, we need to type 3, 4 at the top. It will automatically adjust the size of the matrix. If you have an older calculator, you won't be able to see them all at the same time. You'll have to scroll to the right in order to see all of them. The newest, most updated operating systems make it smaller so you can see it all at the same time. Then all you do is actually type in the coefficients, no variables, just coefficients. So kind of like we do with synthetic division. So I type a 3 because that's my first coefficient and I press enter. It is automatically going to go all through the first row. So I just keep pressing enter. That's a -4, then a 2, and then an 18. Sorry that the equal signs kind of looked like negatives, but if it's negative, you can see that after it. But if you press enter after every single one, it will automatically then move to the next row. A plain X means the coefficient was 1, then 5, then -3, and then -15. Final row, 5, 2, 3, 20. Oops, I did not press 20, I pressed 2. That is also why it's very important that you double check to make sure you didn't make a typo, because if you make a typo, then you're going to think your answer's wrong, even if it is not wrong. So now I double checked everything. This is what the augmented matrix should look like. And so we did this. We defined it to be a 3x4. We entered everything. Now we're on step 4, which says return to the home screen. So press second and then mode. And now I have to go back into the matrix menu, but choose math. So I go to second matrix, but instead of edit this time, I go to math. And I need to find where it says RREF. That stands for reduced row echelon form. It is faster, I believe, to scroll up than down, but on mine it is choice B, RREF. Do not choose A. REF is not the same. It will not give you what you want. So once I select that, my home screen now says RREF. So now I have to tell it where is the matrix that I want to perform this operation on. So press second matrix again. This time we choose names. So we started with edit, then we used math. Now we're using names. Mine is obviously in matrix A. So then I close my parenthesis and I press enter. What this is telling me, because my first column were the X's, my middle column were the Y's, my third column were the Z's, and my very right side column were the constants. So getting it to spit out the answer is good, but you have to understand what it's telling you. This is saying that top row is saying X equals 2. The middle row is saying Y equals -1. And the bottom row is saying Z equals 4. So you can see that here. I have also at the bottom told you how to identify no solution and infinitely many solution cases with matrices. If it is a no solution, you will have 3 zeros in a row. So instead of a 1 somewhere, you've got 0, 0, 0, but then you've got a 1 at the end. If it's infinitely many, because that's kind of representing 0 equals 1, which is false, right? No solution. Infinitely many, you'll have a row of all zeros. And you're not going to have these things in cases where they're not. You can't have something that actually has an ordered triple solution that also has a row of all zeros, right? It's going to be one of those three things. Either I have this nice diagonal ones, and this is my ordered triple, or I have 0, 0, 0, 1 somewhere for no solution, or all zeros for infinitely many.